Good morning, everyone. Last time we talked about the different parts of waves. All right, today we're going to look at those different parts and discuss how they interact, how they're related. So if you increase one, how it affects the other, or if you decrease one, how it affects the other. So just to review, last time we identified the crest, and we're looking at a transverse wave. So the crest of a wave, they're the highest point, the top or the peak. And you have multiple crests in any section of a wave that you're going to look at. Then we said the bottom part of the wave, or the lowest point, is called a trough. So trough there, trough there. All right. We also identified the amplitude, or the height of the wave. All right, so we said that the amplitude is a measure of or from the resting point, the line going through the middle, to the top of a crest, or the resting point to the bottom of a trough. Right? Both of those numbers are going to be equal because the wave is symmetrical. The dimensions on the above the line are the same as the dimensions below the line. Then frequency. So frequency is the number of waves produced in a certain amount of time. So if we said that we're looking at a wave that occurred over a 5-second time interval, we have one complete wave right there. So remember, you have to have a complete crest and then a complete trough, right, to make one complete wavelength, or one complete wave. Then here to here, we have two. So two complete waves in a 5-second period of time. So we gave an equation for actually finding the frequency. You don't really need to know the equation as much as the different parts of the wave and how they're related. But just keep in mind, of the different ways that you find frequency. Then we found the wavelength. All right, so wavelength, measure of a crest to another crest, or a trough to another trough. Remember, you can do it either way because the wave is symmetrical. So there to there. So crest, crest, trough to trough. Very good. So the first property that we want to discuss is amplitude. So looking at the picture, we have two waves. So we're going to say this is wave number 1, wave number 2. And both portions of this wave that we're looking at occurred over a period of time of 5 seconds. So to find the amplitude, we said you measure from the resting point, the line going through the middle, to the top of a crest, or the resting point to the bottom of a trough. So if you look, for either part, you have one whole block. So what we did in wave number 2 is we increased the amplitude. How do we know that? Well, if you measure from the resting point to the top of the crest, or resting point to the bottom of a trough, you can see that we have now approximately 1.5 blocks, all right? So the amplitude now would be 1.5. So you should see how the amplitude, an increase in amplitude, affects the other parts. So if you increase the amplitude, the frequency is also going to increase. So to find frequency, we said the number of complete waves. So we have one complete wave in wave number 1. In wave number 2, we have, there's one there, and another there. So 2 complete waves in wave number 2 versus 1 in wave 1. So increase in amplitude results in an increase in the frequency, right? And looking at the wavelength, right? So wave number 1, our wavelength from this crest to this crest. So we start, let's see, 1 block, 2, 3, 4, 5, 6. So the wavelength would be 6 blocks. Looking at the wavelength for wave number 2, all right, I'm going to measure from here to here. So 1, 2, 3, or say 3.5. So the wavelength decreased, right, as we increased the amplitude. We made the wave taller, therefore the wavelength is going to become smaller. Think of increasing the amplitude as like pressing the ends of the wave together, or kind of smashing it together. All right, when you do that, it's going to force the amplitude or the height to go up. All right. Then looking at frequency, so we have wave 1, wave 2. We're going to say 2-second time interval. I'm just making up numbers. So looking at wave 1, the frequency, we have just one complete wave. Wave 2, we have 1 and 2. Alright, so you can tell we increased the frequency because wave 2 has more complete waves. So when you do that, when you increase the frequency, you're also going to increase the amplitude or the wave height. So to prove that, we measure from stationary line to the top of a crest, or stationary line to the bottom of a trough. Right? Really, those numbers should be exactly equal. It's just a little bit off in this picture. But we're going to say the amplitude for wave 1 is 1 block. Then amplitude for wave 2 is going to be, I'm going to say 1.25. Alright. So, although it was a slight increase, it did go up. Then, when you increase frequency, alright, what happens to the wavelength? So, if you look at the wavelength for wave 1, so we kind of start half a block here, so 1.5, 2.5, 3.5, 4.5. So approximately 5.5 blocks for the wavelength for wave 1. Wave 2, on the other hand, we have 1.5, 2.5, 3 blocks. So increase in frequency, the wavelength is going to decrease. Alright, then wavelength. So looking at wave 1, so once again, time is going to be constant. It has to be if you're comparing two waves. So the wavelength for wave number 1, measure from crest to crest. So we have 1, 2, it's going to be about 3 blocks. Now wave 2, you're going to have 1, 2, 3, 4, 5, approximately 6 blocks. So we basically doubled the wavelength. Alright, so if we do that, the amplitude or the height is going to decrease. Alright, and you can tell because we find the amplitude for wave 1, the height, it's going to be 1 block. Then amplitude for wave 2, if you look at either crest or either trough, right, it's going to be less than 1. So I'm going to say like 0.8 of a block. Alright, I'm just estimating there. So increased wavelength, amplitude, or the height is going to decrease. And then the frequency is also going to decrease. So to measure frequency, we have 1, 2 complete waves in wave 1. And then wave 2, we just have 1 complete wave. So think of this as being like the wave is just stretched out or pulled apart. Right? So when you pull it apart, you're increasing the wavelength, right? Decreasing the amplitude, and decreasing the frequency. So you're going to go through a simulation online that shows you or simulates the movements of the different types of the properties of the waves, and you're going to be able to easily see how they affect each other.